Okay, let's do this last one. If I'd have gone here, if I'd have been patient and just gone here, now watch what happens with here. It starts off references. Okay, doesn't look like much, but then there it goes. That's what was going on. Okay, and so it said it's mounted on the floor and is oriented vertically. That's what was going on. Okay, so first of all, it's got to have a max acceleration. Okay, the max acceleration down here at the bottom to get this thing to flip off, it's got to be equal to g. So it'll have like zero weight when it's up there or whatever. All right. So that's what's going on with this thing. All right. So we can close this. So let's take a peek. So K, I'm going to write down all the stuff we know. K is equal to 115 newtons per meter. All right, and it's mounted to the floor. And then the mass, oh my goodness, you know what we got here? 0.15 kilograms. Look what we have here. We've got a K and we've got a mass. Do you think I've got an omega? And do you think I can find the frequency without much trouble? And then once I do that, can I determine the amplitude to give me that is equal to 9.8? So here's the deal. Here's what we're doing. Okay, so I need to find the frequency, and I need to find the frequency, and I need to find the amplitude where it will lose contact with the spring. In other words, I got to make the acceleration equal to 9.8 meters per second squared. All right, because here's what's going on. There you go. So here's problem 23. I don't know why I didn't figure this out earlier. So look, omega is equal to k over m. All right, so the frequency, omega, is equal to 2 pi times the frequency. So the frequency is this omega over 2 pi. And that's what I was showing you earlier. You had this goofy looking thing. There's the frequency. That's not too bad. Now, when this thing is smooshed down, okay, when it's smooshed all the way down and is not moving, okay, then the maximum weight, the weight of this thing is equal to mg. All right, that's the force that we need. And so the acceleration to get this thing up, to get this thing to fly off when it finally gets up here, I'm going to need an acceleration that is a max that is equal to 9.8 meters per second squared. And we've already talked about a max is equal to a times omega squared. Okay? Right? And so it needs the I got to solve for a. I got omega. So 9.8 is equal to a times k over m. And then mk, or ma, that's a force, divided by k, mg over k is equal to the amplitude. Well, duh! F equals kx. mg is ka. mg over k. Wow. Kind of went around the bend for that one. It even gets easier the fourth time you solve the problem. All right. See how that works? You keep solving the same problem, you gain insights. That was a teaching point, actually, for my blunder.